video is the 2014 Ordinary Level Section A. The first question is a conics question. So the drawing on the right shows the major and minor axes of an ellipse. A portion of the curve is already drawn. So locate the remaining points on the curve and draw the ellipse. Then part B is to locate the focal points of the ellipse. So they have given us our major and minor auxiliary circles, and they've found 1 point on the curve first. So what we're going to do is going to continue with the major auxiliary circles method. So line from the center, 60-30 degrees. So each point, so I'm going to take each line in turn. So I'm going to take, let's say, this one here first. This line cuts the major auxiliary circle at this point, so I'm going to go perpendicular to the major axis, which is vertical. So perpendicular to the major axis is a horizontal line drawn this way. That same line cuts the minor auxiliary circle here, so I'm going to go perpendicular to the minor axis from that point. That gives me a point on the curve here. Same thing from the next point, next line, so perpendicular to the major axis as it cuts the major auxiliary circle, perpendicular to the minor axis as it cuts the minor auxiliary circle. Gives us points in the curve. So we got 4 points there now. Doing the same thing for up on top. Perpendicular to the minor axis, perpendicular to the major axis, another point here on the curve. So we can draw on this side of the curve. Now the state exam solution does a mirror, so it'll do an axial symmetry across the other side. That's an okay solution to do if you wish. I'm going to continue doing the auxiliary circles method. So perpendicular to the major axis from where it cuts, the lines are cut by the major auxiliary circle, and then perpendicular to the minor axis where those same lines cut the minor auxiliary circle. So that gives us a few more points here and here. This point. And that completes our drawing the curve. So the final part of question A1 here is to find the focal points. So the focal points are found by measuring half the major axis. So measuring half the major axis here, and putting the point by compass then onto the end of the minor axis, swinging an arc so that it cuts the major axis. It'll cut it in 2 places. So here and here. And there are 2 focal points. Make sure you label them F and F1. Question A2 is an orthographic projection question. So the 3D graphic below shows one section of a Lewis tram. The plan, elevation, and partially completed end view of the outline of the tram are shown on the right. So complete the end. Part A is to complete the end view of the tram, so to complete this view. Part B is to draw the end elevation of the power supply connector on the top of the tram. So it's just this bit up here that we need to draw for part B. So what we need to do is we need to record we need to change or draw the front part of this here. So taking each piece, so this one across, rotate it around just like all the other points have been. Point here rotates and then can be projected up at the correct distance. So this point here is at the front, so this is going to be this point on the front of the tram. Going to do the same for the back corner. Just taking that point, this one rotates. And this point is at the very top, so that's this point up here. So that's going to go the whole way up. So this one, this point, as I was saying, is this one up here. That's going to project all the way up to the top. So that gives us that upper point up here. So the front of this tram is going to look like a line joining from the point that we just found here up to the second point that we just found. So joining these two. The front of it then is going to be a line that comes across here. Because that's based on this line here. And then we've also got two vertical lines here at the front of this. So we have one of them already, so we need this one. And then also this changes direction, so this goes, it's a straight line this way, it then changes direction going here, which indicates that there's going to be a line, so we need a line coming down along this way. So that's the visible part of what we have. We already have the back corner. What we don't have are this corner here and this corner here. So they've given us the position for this line, so it's given us that top edge. But what that also means is that just because there was a visible line here, there needs to be a line indicating the change in direction on this side. So that's going to be a hidden detail line. And same for the point here, for the back corner. So in here we're also going to have a dotted line, hidden detail line. And that's showing us this back edge back here. So that completes part A of this question. The next part of it is to draw the end elevation, so the end view of the power supply piece up on top. So we're going to take each of our heights across because the heights are going to stay the same. Now we're going to need to locate the different widths down here in plan. Now there are very faint marks here, which are the marks for the bottom parts of that. So first we're going to take all the heights across. So project the height, they're both elevations, just one's an end elevation. So the heights are going to stay the same. It comes across this way. And then each of the points, so I'm going to take the outer ones first. So the two outside points are the two top points up here. So projecting these all the way up to the top line and here also. So that's a point and another point. I'm just going to darken in the line between those 2 points just to make it a bit more obvious. Next thing I'm going to do is I'm going to do the bottom points. So on the question there's two very faint marks there, that's those ones. If you can't see them, just project them from the top down, from the elevation into the plan. That'll locate those points. So again, we're going to project these up into the end view, same way that we have for all the other points, rotating them around and project up into the end view. That's almost this completed, so now it's just this arm that joins the two. So we need to take both of these points and that's our line here. So we have where it touches the top, this one, and where it touches the bottom down there. That's the other point. And that finishes question A2. Question A3 looks at solids in contact. So the drawing on the right shows the elevation of a cone A. two spheres B and C. All three solids rest on the horizontal plane, so they're all touching the ground line and are in mutual contact, so they're all touching each other as well. The plan of cone A is also shown. So part A of this question is to draw the plan of the sphere B, so that's the large sphere, and part B is to draw the plan of sphere C. So what we're going to do first is we're going to project the center from B down into the plan. It's going to be down here somewhere, so the center is somewhere along that line, and we need to figure out where. If we ignore circle C or sphere C for the moment, we can see that B and A touch off each other and they don't appear to overlap each other. What that tells us is that the center from A and the center to B are horizontal to each other. So if I take a horizontal line from A, the center of A, the center of B is on the line along there. So that's the measure. I'm just measuring the radius to B here now, and I'm going to swing, draw this sphere in plan. And we'll just draw that lightly first. So that's sphere B. So part B of this question is to draw the plan of sphere C. So again, we know the center is going to be somewhere down along, is directly below it where the center is in the elevation, so somewhere down along that line. All we need to figure out is where. So we need to be able to see where it touches either the sphere B or cone A. It's easier to draw this if we draw it for cone A. So what we're going to do is we're going to draw the sphere C in a position here where we can see where it touches the ground and the side of the cone, because then we'll be able to determine how far away the center is from the center of the cone. So it still has to stay touching the ground, so it's going to be that distance off the ground. And what I'm going to do is I'm going to take a line perpendicular to the side of the cone, just to measure off of. So anywhere up along. And I'm going to measure the radius of C now next. I'm going to add that onto the line that I just marked a moment ago. So again, going parallel to the side of the cone. Everywhere along this line I could draw a sphere of radius C that would touch off of the side of the cone, and where anywhere along this horizontal line I could do the same thing where it would touch off the XY line. Where they cross each other is a point that will do both. It will touch the side of the cone and the ground line. So I'm going to take that point, project that into the plan, and this is how far away the center of the sphere is from the center of the cone. So what I'm going to do now is I'm going to rotate this around into its correct position, and that will give me the center for C down here. So I rotated this around this way. This is the correct position for C, where it's touching off of A and B. So now I can draw the sphere C in that position. So now I just need to figure out what's visible and what's not. So most of C will be visible. So this is a dark line. So use your compass or very carefully trace around it. But it is hidden detail for where it goes in underneath sphere B, just a small bit. All of sphere B is visible. And for cone A, it's visible for only a small bit of it, and it's hidden detail in underneath the two shapes. Visible here. And hidden again. So that is question A3 completed. The Final question on this paper is question A4, which is a perspective question. So the 3D graphic on the right shows the Melbourne logo displayed on a billboard. The logo is designed to look like pages from a book. The partially completed drawing below shows how the logo is constructed using 2 vanishing points. So a vanishing point here for all the pieces on the right, vanishing point here for all the pieces on the left. Partially completed drawing below shows how the logo complete the drawing is what we need to do. So we're going to start with the pieces on the left. So each of the points here on the left are going to join to the vanishing point on the right. So they've already kind of started these lines for us. So I'm going to join all of these back. So dark line as far as there. You don't need to go the rest of the way. Same for this one, onto the vanishing point, dark line as far as the solid line here. And then we'll join this one lightly back to that vanishing point. Going to do the same thing for the ones on the right now, working back this way. So from the point down here to the vanishing point on the left, where that crosses the previous line that I've just drawn, this one gives us where they're going to stop, or where they're going to be visible lines from. And then we've got this here through the center. So I can do the same, continue on going on the right, so back to the vanishing, so from the points on the right back to the vanishing point on the left. And I'll come back to doing those two in a moment. So the ones on top, again, join to the vanishing point on the left. So the points on the right join to the vanishing point on the left, and the ones on the left join to the vanishing point on the right. So to get this piece up over here, we're going to be doing things slightly backwards. So we're taking from the point on the vanishing point, and we're given a bit of the line here. So from the vanishing point, I'm going to extend this line out. So I need to find where the end is going to be there somewhere. Going to do the same thing from this line. So taking from the vanishing point on the left, extending this line out this way. So somewhere out along there. And then I'm just going to take these vertical lines here, extend them down to meet the first ones there and here. That gives me this bit here, this here, and then I can darken in the 2 lines that I didn't draw fully. So that is the logo completed, and also completes the 2014 short questions.